So we've reached the end of the second TwinBrain workshop. Thanks for everyone for sticking with us for so long. It's been a long day, a lot of nice scientific creative input. We've heard contributions from several amazing scientists and people. And just a final few remarks. And maybe Uroš, I would like to ask you the first question. So what do you take? What are a few take-home messages? What do you take away from these 3 days?
I guess a great question for all of you. So I hope you enjoyed the workshop. You've seen like the progress from the first day until the last day. Moreover, if you were following us from the first workshop that we had in Berlin last year, you could see how we are evolving and trying to upgrade these stages that were initially planned. So when we were submitting the grant together with Klaus, with Paolo and Christoph, we were thinking how to make this progress in a way of conducting 4 different workshops. So the first one was very much about the analysis, MoBI applications, data cleaning, automatic pipelines, different toolboxes that can be used in data processing and so forth. And then we moved now forward to 3 different areas. So since in the first workshop we were just mentioning briefly what is important about gate analysis, this time we had like the whole day related to basic biomechanics, human movement analysis. You learned about the basically subsections of biomechanics like kinematics, kinetics, and EMG. And from that, how you combine all this knowledge in clinical settings. So why is it important to understand it, how to extract the feature, why the force and torque is important during different gate cycles, and how this relates and how the experts are interpreting that per se. So not even looking to the brain or let's say decomposing muscular activity. So that was the first day, and I think that was lots of information to process. I think we made a great impact showing the very basics of clinical aspects of biomechanics, and then moving forward to whole body kinematics. So all of a sudden we have now opportunities to stream 3D avatars in real time for representation purposes, but also like to conduct real experiments. So somehow I can say that the first day was very much biomechanically related, and then we moved forward, right? So we had the second day in which we were digging into very specific details of how peripheral nervous system or even central nervous system then controls the muscle activational patterns. So we were able to decompose different components inside and track different individual motor units. And after that, you could see different applications from the even fatiguing or different pathologies and in patients, as Alessandro Del Vecchio nicely showed after Aleš Holobar, for instance. So that was very indicative and very, very specific to the muscular activity. And then we moved forward, right, on the third day to the sort of like supraspinal mechanisms. And we started with basic designs, how to conduct an EEG ERP experiment, then how to properly clean the data. And you, I guess, realize that we don't have a recipe A to Z, but you need to find your own way. And we are trying to unify these protocols. So that's an extremely important information. And also then that there are new classifiers that are being developed to being used in use for MoBI setups. So last but not least, 2 very, very interesting aspects. So like cortico-cortical and cortico-muscular coherence, to understand detailed communication between the brain and the muscle, or the different brain size or different brain areas. And then the last, which was the time frequency neural time series analysis. So with that, I hope we we provided a comprehensive overview and somehow gave you this information in which direction we want to go. So having a subject, healthy subject, walking, naturally walking over ground walking, and then conducting several secondary tasks while measuring cortical activation, muscular activation, and of course the behavioral results like how biomechanics in general. So this workshop was meant to give you this information. We are looking, of course, forward to your feedback and to give us more details. What would you like to learn? But in general, there is like more coming, and in the third workshop we will be digging into more clinical aspects, and our Italian partners will be giving this proportion of knowledge, how MoBI can be implemented even more into clinical settings. And then we end up with the fourth workshop, which will be then done here again, and we'll be dealing with big data analysis, machine learning protocols, and other aspects that can be then implemented into MoBI approach.
Thank you. Klaus, you are one of the pioneers of the MoBI approach, and I wanted to ask, like, so when you look back to the very beginnings, maybe in 2010 or even a few years earlier, when you started thinking about MoBI, when you started, creating new ideas about how you could record brain activity in a more natural settings, in terms of embodied cognition and so on, and you look through this time that elapsed until this point today, what are your reflections on the progress that happened in the field of MoBI, and where do you think we can go from here?
I think the progress we made was amazing. So we started somewhere around 2006, and we started with lab-based, very small movement ranges. And I do remember specifically that Scott McCaig and I submitted a proposal to Trends in Cognitive Science about upcoming trends in cognitive science, neuroscience basically, to measure mobile brain-body imaging, and was rejected because it was highly implausible that would work. And from there, like 15 years later, what we see is an amazing wealth of really, really nice studies that address gait, that address clinical aspects of gait already, treadmills, but also natural overground walking. We are talking about experiments that are conducted in the wild, in the real world, using eye blinks to basically investigate the neural dynamics underlying cognition. So we had an amazing development within 15 years that makes me very hopeful that this trend will proceed in the near future. We will see more experiments, more controlled and better technology that we can use in the wild, in the real world, but also in the lab, and that can be expanded to different areas, as it is already that we can see right now for clinical purposes, but also in therapeutic interventions and things like that. So I'm super happy to see what happened in this time range. What we need, I guess, to really proceed from here is robust results. I think I said that in my talk previously. We need to replicate experiments. We need to replicate approaches to develop some kind of standards in mobile brain-body imaging. We need to look at the tools like we just learned about. How to best analyze the signal, how to best pre-process MoBI data that inherently come with a lot of noise that might not be brain-related activity, but nonetheless interesting activity to better understand what is going on when participants actively behave in the environment. And these analysis tools, when it comes to analyzing the already recorded signal, is just one dimension. We also need better synchronization tools to allow for a highly reliable synchronization of all the different recording modalities that we work with, like EEG, EMG, FNIRS, optical tracking, video-based tracking, but also what can we do with sensors in smart environments. So can we communicate and use technology that is already out there in the world to just feed information to people that might, record their ECG, EMG, and potentially in the near future also continuous EEG, why they behave during their natural daily activities, can we track context information from sensors that are embedded in buildings, in the environment in general, to get like big data actually from participants that like to contribute their brain dynamic data on a daily basis. And that's where machine learning and all the other approaches will come in. So that would be the second side. And then the third side basically is, I think, the hardware that will be crucial. And we've seen a very steep development when it comes to mobile EEG. Portable EEG technology that comes with sensors, 64 sensor setups that can be amplified in like a pocket amplifier and still deliver like very good signals. So I see this technology to improve in the near future. I think the biggest problem we have is the noise based on sensor nets that we have to use outside the skull. So, and the question is, what will be the next significant step to get less noisy signals, to be less obtrusive? So usually people don't really like it to run around with 64 channels gel in their hair running around in the city. That's uncomfortable. So I think that's the next and maybe the last barrier really to overcome, that EEG becomes a daily tool to record brain dynamics 24/7.
Uroš, as the PI of the TwinBrain project, so when submitting the application for the project, you also envisioned like several of this kind of events, right? Besides the state-of-the-art combination of technologies that allow the mobile experiments, so the MoBI experiments, and all these events are basically targeted to different groups, right? For example, as you already mentioned, the workshops, 2 of them already behind us, 2 of them are still ahead of us. Can you maybe give us a bit, can you give away more information about the upcoming workshops?
Yeah, sure. To be frank, like, of course, when you're submitting some ideas, the only constant is the constant change, right? So you learn while doing things. Big thank here to Klaus Gramann and his lab. We learned a lot. You can confirm that. And it's kind of like a new world for us, like moving from the stationary EEG to mobile EEG per se, and like discovering all the whole spectrum of features that we needed to learn from basically scratch. So these ideas were basically there, like as a basis, but then we are constantly trying to upgrade them with different protocols. So as I mentioned previously, we will be moving towards the clinical application. So the ideas how to measure basically the cortical resources and what is cognitive motor interference in the end, and to give to the neurologist the application where they will be willing or to use it. That's kind of like a long-term or mid-term plan. But to do it so, as Klaus mentioned, there are several issues to check, so to learn, to unify protocols, to have different opinions, groups working from different fields on the same topic. So I'm convinced here that this multidisciplinary approach, like having engineers, having then psychologists, kinesiologists, physiotherapists, and other medical staff, if I forgot somebody, to work together basically on one topic which is very broad. It's the key aspect to have success in the end. And I hope you will be learning that with us and, giving us also the input. What is next? Of course, like very, very soon, in 2 days from now or in 3 days from now, we're starting with the summer school. So that's an event that gives you a more horizontal overview of the MoBI, or let's say neuroscience of movement in general. And then after that, at the end of the year, you will be receiving new information regarding workshop 3.0, which will be then dealing with clinical aspects.
Thank you. So on behalf of the TwinBrain Consortium, we would all like to thank all of the participants online, all of the speakers. My special thanks to the people, to the speakers, professors that came and show up here in person. And we would also like to thank you who participated online, asking questions, being there. You actually are the reason that all these events are happening, to network, to exchange ideas. So yeah, thank you for all your input to this event. And as already mentioned, we would like to invite you to register for the summer school. You can register online via the TwinBrain website, so www.twinbrain.si. And please do. It's a free event. You can just register and listen to our sessions and get to learn more of this horizontal knowledge that bridges several disciplines. You will also, all the registered participants will also receive the feedback form, and we would love to know what we did good, what could have been improved, where's the room for improvement, and please be honest and just answer in a very sincere manner, because yeah, we said 2 more workshops ahead of us, and we would really like to just offer the knowledge in the best manner we can. So thank you again to everyone, and I hope to see you soon at the next workshop, summer school, or maybe even here in person. Thank you.
Thank you so much.
Thank you.